All right, so in this video, we're going to start to talk about percent of change. So this is the basic idea, which we can kind of see up here. When a company buys product, they need to increase the price before it is sold, so they make a profit. So that's a very basic idea. If I buy, say, this item here for $2, well, I'm not going to sell it, I don't know why I said $12, $2. I'm not going to sell it to you for $2 because then I wouldn't make any money off of it. I'm going to increase that price, so I'm going to increase it by some amount so that I can make some money off of it, right? So that's a basic way of using percent of change. We can also have it go down. So maybe I have a sale on this item, so I'm going to bring the price down because I want to get rid of it for some reason. Maybe it's not selling well, or I'm just, trying to get people in the store. Sometimes that's a good way to just get people in the door, is to have a sale on an item that that they kind of want, something like that. So there's a reason to increase the price. There's a reason to decrease the price. The second sentence here talks about decreasing. So sometimes items will go on sale or have special coupons that will decrease the price. Depending on the situation, you will have different information. So we have to read each problem carefully and make sure that we understand which information is being given to us. And we're always looking for three pieces of information. The new price. So what is it after either the increase or the decrease? What's our new price? What was the original price? And then the percent of change. So how much did it actually change by? And the little equation that we're going to do is new price equals the percent of change times the original value. So that's why we're looking for those three pieces. We need that for our little formula here. And keep in mind, percent of increase and percent of decrease, that's not just saying the item is on sale for 20% and 20% is my amount of decrease. That's how much it's off. The percent of increase or decrease has to do with the 100% that the item cost me, either plus an increase or minus the decrease. So we're looking, it's a little bit more than just what's the percentage. We want the percent of increase or percent of decrease. So in the equation 100%, we actually write as 1. We don't write it as 100%. We turn it back into a decimal because I take that decimal and I move it back twice to turn it back into to turn it from a decimal to a, turn it from a percent to a decimal. Losing my words there. All right, so let's go ahead and practice this. So finding the percent increase or decrease, basic. So we have the price of an item has dropped to $63 today. Yesterday it was $140. Find the percentage decrease. So they're telling us that it's a percentage decrease, which was nice of them. So they're already giving you that clue. If they didn't give you that sentence, we could just think about it. We could read it again. The price of an item has dropped to $63 today. Okay, well, it's today, right now, it is $63, and it dropped. So that must mean it's decreasing from something. And right now, the new price, what I'm going to pay for today, is $63, right? And then yesterday it was $140. Okay, so now I know what it dropped from. It was $140. So that was my original price. So that's a pretty good drop, honestly. That's over half the price of the original price, or $63 from $140. And the percent of change, so remember it's going to be the 100% minus the percentage that it changed by, because it's a decrease. That's why we're subtracting. And instead of saying 100, we write it as 1. So it's 1 minus X. X is going to be our discount, our percentage that it dropped. We don't know that. That's what we're trying to find, the percentage decrease. So percent of decrease is different than the percentage decrease. They sound similar, but wording matters. So this is the percent of change, 100 minus the percent decrease. X is the percent decrease. That's how much I actually had off. If I got to walk in the store and I saw 20% off, that's my percent decrease. That's not the percent of decrease. So be careful about the wording there. All right, so now we're going to put it into our little formula here. So we have our new value, which was $63, equals 1 minus the percent decrease times the original amount. So now what we're going to do is we're going to distribute the 140. So you can actually do this two different ways. You can distribute the 140 to both of these because we're multiplying by binomial, or I can divide by 140 because the entire side is being multiplied by 140. Either way will actually get us closer to our answer. It just depends on the method you like. So I can show you both really quick just so you know what I'm talking about. So if I distribute this, I have 140 times 1, 140 times negative x. So I'd have 63 equals 140, because that's 140 times 1. And then minus 140 times x, so minus 140x. Or I could have divided both sides. So let me rewrite it real quick so you can actually see it. So since I'm multiplying this entire right side by 140, I can divide by 140 and divide by 140. That cancels, and that would also get me a correct, not a correct answer yet, because we still don't know what x is, but it would point me in the right direction anyway. It's going to give me a decimal, so I would end up with 0.45 equals, and all I have on this side, because 140 divided by 140 cancels, is the 1 minus x. So I still have 2 steps either way, because this I'm going to have to subtract 140, and this is not 140 being subtracted. This is negative 140 times x. So I'm subtracting this positive 140 here. I know they're both 140, but they're different because one is a constant and one is being multiplied. So now I have 63 minus 140, and I get negative 77. And remember, this is a negative minus or plus a positive, or a positive minus a negative, depending on how you're reading that. So you want to look at which one is the bigger number, or which one has more. 140 is definitely more than 63. So my answer will be negative because there's more negative than positive. And then I can just subtract like normal, like this. So I can just write this and go, well, I have to borrow here. 10 minus 3 is 7. I'm going to have to borrow again here. 13 minus 6, that's another 7. So I get 77. But because 140 was more and it's negative 77. 140 minus 140 cancels. And then I get negative 140x. And now I can deal with this negative 140 being multiplied by the x by dividing by negative 140 on both sides. See how I divided by the 140 over here first because the entire side was. So either way, I have to end up dividing by the 140. So this is going to be negative 77 divided by negative 140. So I end up with 0.55. And Alex will give you a calculator on this one if you do not have a calculator of your own. We also have calculators in the center for you to borrow at any time. But this one definitely is going to need a calculator just for kind of sake of ease of getting through the problem, because we're going to have to deal with a lot of decimals on this one. So 140 divided by 140 cancels out, and I just have x. So what they want, though, since they want it as a percent of decrease, this is the decimal form. I want to take that decimal and move it 2 times to the right, and that turns it into a percent. So it's 55%. So it was 55% off the original. So it's a pretty darn good discount, honestly, since it dropped 55%. Okay, so I could have done the same thing over here, where I would have subtracted 1 for both sides. And then it's negative 1 plus 0.45, so I want to subtract that, so I end up with 0.55 negative, because 1 is bigger than 0.45. That's a whole 1. This is a decimal. And that's going to equal 1 minus 1 cancels, so just negative x. And then I don't want to know what negative x is, so I end up pushing it over here to the other side. It's the same idea as dividing by negative 1, since I'm multiplying by negative 1 here. So I'm dividing both sides by negative 1, and I end up with 0.55 equals x. So we can see I end up with the exact same percentage, which is 55%. Either way I do that, it just depends on which way makes more sense to you. I know when I've suggested doing this in class, where we can do the division first, it tends to throw students off because it's not the pattern we normally go with. But it's perfectly fine to eliminate that multiplication instead of distributing it if the entire side is being multiplied. So if we had extra pieces here, like if I had, a plus 1 on the end, okay, now I can't do that same method because I'm going to have to apply it to everything, not just underneath the whole side. So just be careful about that, but it's just showing you there's more than one option. All right, so we're going to read the next one here. So I wrote a little bit on that next one. The price of an item yesterday was $110. Today the price rose to $297. So without even reading the third sentence, if I think about the words that I just read, the price of an item yesterday was $110. So that's the past. That's going to be my original price. Right? Yesterday was $110. Today, that's right now, that's going to be my new price. That's what I'm paying right now. It rose to $297. So my new price is $297. My old price was $110. And then I also heard the word rose. It rose. It went up. It's an increase. So the last sentence says, find the percentage of increase. So now I have 100% plus the increase. Whatever that percent of increase is, it was a markup. So we can think of it as I bought it for $110 and I'm raising the price to $297. That's a pretty big increase so that I can make some money off of that. So now I have my new price equals 1 plus X because it's an increase. So it's adding the X, it's adding the percent increase. And that's going to be times the original price of 110. So same thing. I can do the exact same thing I did on the last one, where I can distribute this 110 and work it out, or I can divide both sides by 110 right off the bat. And with this one, let's see, 297 divided by 110, we get 297. I think I typed that in wrong. Divided by 110. Oh, nope. Okay, so I get 2.7 equals 1 plus X. Because the 110 divided by 110 cancels out. Anything divided by itself is 1. So it's no longer on the right side. I moved it to the left side. So now all I have to do is subtract 1 from this. And 2.7 minus 1, that's just going to be 1.7 equals X. Remember to move that decimal place 2 times. Since I don't have anything right here, it gets filled in with a 0. So I have 170% increase. Okay, so this went up 170%. And that's on top of the 100% of the 210. So it's 110 plus another 170% increase. Because it was a total 2.7 percent of change. So it went up quite a bit. Which, if we think about 110, what's 110 plus 110? Why is it doing lines now? That's weird. There we go. So 110 plus 110, we get 0, we get 2, we get 2. So 220 would be a 200% increase because it's the first 100% and then another 100% of the original cost. So that would be a 200% increase. Well, it went up even more than that, right? So that's kind of how we can make sense of that. So the first value, that's 100% of the cost. And then whatever we either add or subtract from that, that's how we determine how much it's going up or down from that original price. Because we're always basing it off of the first cost, the original 100% of the item. Okay, so that's what that means. All right, let's look at this last one here. We have the price of technology stock has dropped to $9.59 today. So just looking at that first sentence, I'm not even going to read the next one yet. So it dropped, that's a decrease. That's a decrease word for sure. It dropped. Today, that's a now word, right now, new. So I know my new value is $9.59. That's going to be my new value. That's what it is right now if I bought it today. Now, if I read the second sentence, yesterday's price was $9.72. Okay, yesterday, that's the past. So that's a keyword. So it was $9.72. That's my original value. If I bought it in the past, the most recent past, which would be yesterday, it would be $9.72. So find the percent of decrease. We already knew it was a decrease because it dropped, right? So percent of decrease, and they're asking us to round to the nearest tenth of a percent. So we're going to end up with kind of a funky decimal in this one. We're at the longer decimal, and we're going to have to round it. So since we know it's a decrease, and I kind of cut it off a little bit here on the bottom. Let's see if I can scooch this up just a little bit so we can see it. So it's a percent of decrease. So I'm going to go down here. Is this a decrease or increase? Well, it's a decrease. So I know I'm going to use 1 minus x. So that's why I put these here as a little key to help you. Remember, if it's an increase, you're using 1 plus x. If it's a decrease, you're using 1 minus x. So now I'm just going to plug it into my little formula. I have my new price times 1 minus x, and it's the quantity of 1 minus x, the difference. And the original price was $9.72. So I'm going to use my same method that I used here because I think it goes a little faster. I'm going to divide by 9.72 on both sides. So I have 9.59 divided by 9.72. And definitely I would suggest using a calculator. I'm using a calculator kind of behind the scenes here. When you use a calculator though, make sure at this point, don't round it off because this one keeps going. This is what I can see on my calculator. And it stops simply because that's the limit on my calculator. But don't clear this. Keep it going. So I'm just going to go, dot, dot, dot. It keeps going. But I'm not going to clear my calculator. I'm going to keep it there. And it's going to be 1 minus x. 9.72 divided by 9.72 cancels out. So now I'm going to subtract 1 from both sides. And I'll kind of draw the line a little bit, but I'm going to write it up here. So in my calculator, without doing anything else, I'm not going to clear anything. I'm just going to go minus 1 because that's going to give me my next number using that whole decimal without rounding. So I'm going to have negative 0.0137. Oops, it's 337, and it keeps going again, dot, 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 equals 1 minus 1 canceled, so I just have negative x. So now remember, I don't want to know what negative x is, so I do need to divide by negative 1 on both sides, so the negatives cancel. And I have x equals, so now there's usually a little swap button on the calculators where you can just switch it, but you can also just do divide by negative 1, and that'll work. But on my calculator, I can see it, I have this little like plus/minus button. And if I click that, it simply drops the negative for me. So that's very convenient. Sometimes it'll have little arrows like this. So you'll see it like that. But it's some kind of little switch button where you'll see the plus minus. And you can switch it from positive, negative, or negative, positive. So that's what that button's for. So now I have positive 0.01337. And they want me to go to the nearest tenth of a percent. So I'm going to move this 2 times. 1, 2. So I'm going to have 1.337. And that's percent. Well, if I want tenth of a percent, first make sure you turn it into percent before you round. Because they don't want just a tenth. That would be the 1 right here. Actually, nope, sorry. Fibbing to you. That would actually be the 0 right here if we were just looking at tenths. But tenth of a percent means after I turn into a percent, then I'm going to look at the number right after the decimal because that's my tenth. So if the number right after at the 100th place is 4 or lower, we just round off. So it's going to be 1.3%. If that were 5 or bigger, then I would round this 3 up to a 4. Basically, when I'm rounding, I'm saying, is it closer to keep it where it is at the 1.3, or is it closer to round up to the 1.4? When you're rounding, you're just determining which one is it closer to. That's all you're doing when you round. So this one, my final answer, and I'll write it up here a little neater, it's going to be 1.3%. So that's my percent decrease. It dropped just a little bit by 1.3%. So that's a pretty small drop. But we can see it's not very much. It went 12, 13 cents down. Did I do that right? Yeah, 13 cents down. I want to make sure I was practicing that right in my head. So it's not a huge drop, but still, it went down. So when we're talking about stocks, that's something that we always look for. All right, so that was the beginning of percent of change. Go ahead and go on, Alex, and give it a try.